5 times 5 is?
25.
Yeah. Hey folks, welcome out there. We are so glad you tuned into us after you've had a great Christmas weekend, holiday season in full swing. We had Kwanzaa going on, oh goodness, on Saturday. So all sorts of great things going on here in the world. And we're glad you've tuned in and chosen to take a little time off and tune into Mathline here over your holiday breaks. And you know what? We're going to be here as a not call today, so don't call that number that guy out there tells you to call. But instead, sit back, relax. We're going to spend some time doing a little more math study here, all right? And hey, you know, you might learn something, get some paper, some pencils, all those good kind of things. Let's have some fun today, all right? And see what we're going to do today to have some fun with, all right? Looks like, importance of being zero. Is that not a great title? It's kind of like a book out there. Oh, that's the importance of being earnest. That would be me, okay? Short is Ernie for Ernest, in case y'all were wondering. I know, over the head. Okay, we'll move on with math. You're here for math, I know. But zero, a very, very important number in our mathematical language, all right? One of the biggest, best symbols around, and today we're going to see some more reasons why it's extremely important. You thought nothing was nothing? Hey, let's see what happens with it. Let's see what we got out for our slate coming up here. The product of zero and any number is always zero. Not a problem, it's a fact. In fact, this is what we call the multiplication property of zero. If you take any number, and I don't care how big, how positive, how negative, any number times zero, we are going to get zero. So if I say something like, let's say 8 times 0, all right? And it doesn't matter which number comes first. If I say 8 times 0, it's going to be 0. If I come along and say 0 times 8, well, you know what? It's still 0. So anytime I pull the number, it's sort of like I could say, well, let's see. Let's write 0 down 8 times as a repeated addition. Well, you're still going to have nothing, all right? So again, this is what we call the multiplication property of zero. So that's one rule that we're going to be tuning in today. You say, what does that have to do with all the stuff we've been doing on factoring lately? An awful lot. So just hang on to it. Now, if I tell you the product of two numbers, and I say, I don't know what the two numbers are, all right, is equal to 0, there's some value A and B, one of those has to be 0. In fact, both could equal 0. Somebody said, well, could we say 0 times 0? Sure you could. And, you know, the thing is, the product either, if for example, we used 8 times 0 here, if A is 8 and B is 0, it's going to give you 0. So in other words, one of these, either A or B, must come out to be 0. And that's going to be the fact we're going to be using over and over today when we work with our factoring problems and doing some algebraic factoring also, okay? So just keep that in mind. You know, I remember one of my favorite shows, the Beverly Hillbillies. Some of you that are our older viewers and more veterans that watching TV in the past and such will remember Jethro Bodine and his able to do the times table. He always starts with his noughts. Naught times naught, naught times 1, naught times 2. That's 0. I love it. Jethro knows the 0 property. He just calls it noughts, okay? But anyway, those of you who've ever watched Beverly Hillbillies, you know he loves to cipher. He loves to cipher, and we can learn a few lessons from Jethro at time too. But let's go ahead and see what we've got coming up our way here. Let me move myself going on here, and let's look at a problem and see, what are you talking about, Ernie? What's all this stuff? Remember, we've been working with factoring, and we've come out with binomials and such, and we want to make these binomials allow something to equal 0. Now, if you remember the property I just basically said, if we are going to multiply two values here, and keep in mind x is standing for a number, all right? One of these parentheses has to give me 0. The x plus 5 parenthesis can do it, or the x minus 4, because see, that's a factor. That's a factor. So one of the parentheses, either the x plus 5 parenthesis or the x minus 4 parenthesis, must equal 0 for this to be true. And that's what we're doing. When we solve, that's what we're looking for. What values will make 0 happen in the multiplication? Now, as I said, 2 times 3 is going to give us 6. So we have to have one of these to be 0. So here's how we work it out. We're going to simply write down x plus 5 equals 0. And over here, we're going to say x minus 4 would equal 0. So there's our two options. Now what happens is we're going to figure out what are the two possible solutions here. And as I said, it's one or the other was all we need to know, but we want to know both options. When we solve for the variable, we are looking for two possibilities here, two possibilities. So this is another bearing. Of course, when we do an equation, and this is a very small equation, as most of you are saying, well, this one's easy, I can do this in my head. I hope you can, and some of you will get there. Some of you will need to write this down each time, and that's fine, okay? So let's see, we're going to subtract 5 from both sides because that's basically what we need to do, get rid of that positive 5. And you know what? We get another deal with 0 because when we subtract 5 from 0, we just simply get the negative 5. So we've got x equals negative 5. So there's our first solution. Does it work? Of course, if we substitute it back in, I've got a negative 5 plus 5, which is 0. Importance of being 0, right there you go. And then that parenthesis will basically, x can be anything it wants to be. If it's negative 5, it's going to wind up being a negative 9 over here for this parenthesis, but it doesn't matter because you got a 0 here. All right, so the 0 is going to take out whatever's going on here. Now, let's look at the right side of this equation. Actually, the one in the middle here, but the right side of the left side. Doesn't that sound a little confusing? X minus 4, let's focus in on that. The x minus 4 equals 0. We want to find out what value of x is going to make that work. So we're going to add 4 both sides, and we'll end up with x on the left, and on the right, oh, there's that good old identity property for addition is when we add 4 and 0, we get 4. And again, you take a quick look. When you say 4 minus 4 up here, it's going to give us 0. And if you put a 4 over here, it's going to give you 9. But you say 9 times 0 is 0. So both of these are good solutions. You look at them one at a time. They will make a true statement. As long as one factor makes 0, we're good. We are good. Now, if you had a repeated factor, well, you could have 0 times 0, which is still going to give us 0. Okay, so importance of being 0, that's what we're looking for. And the importance of doing algebra and the importance of doing some easy arithmetic today, that's also what we're going to be doing. All right, so let's take a look at our next problem here. Up the ante a little bit. But remember what I said. Each parenthesis needs to be set equal to 0 because we're either wanting this to be 0 or this to be 0. But we've got to look at both options. So let's set them up. We're going to have 3y minus your 5 equaling 0. See that, folks? That looks great. Now, I draw a little line here so we just don't get crossed over and messed up. So here we also have 4y plus 3 to be equaling to our 0. Now you say, Ernie, that doesn't look quite as easy as I could do that in my head. Well, that's all right. Let's not do it in our head today, all right? Let's go ahead and work it out. We're going to work out each time we have a parenthesis or each time we have value to work with, we're going to just run it through here. And you're going to find it works pretty easy, and I hope you start getting some ideas after you see a few of these problems. Hey, I can do that mentally. And we'll talk about it in another show. But for today, we're going to work it out, okay, folks? We're just going to work it out. Again, we want to get y by itself here. So let's add 5 to both sides. Oh, there's that property of 0 again, that identity element right there. And we're going to have 3y equals 5. And you say, Ernie, that doesn't go evenly. You're right. So here's what we're going to allow you to do. We're just going to divide both sides by 3. In most cases, we're going to leave this as 5/3. You say, well, could you make it 1 2/3? Sure you could. Sure you could. But when you come back and substitute it, you're going to want to multiply it by 3, and it's just going to be so much easier if we just say 3 times 5 over 3, because the 3's cancel and leaves me with 5 minus 5, which does give 0. Importance of being 0 today. Now let's check out our second one here. Subtract 3 because it's a positive 3. We want to get that over there. So we're going to see what happens. We got a 4y. And here we've got negative 3. And sometimes we get a little nervous when we see this number being smaller than the 4. And you think, well, what do we do? Well, we divide both sides by 4 like we did over here with the 3. We're going to divide both sides by 4. And the 4's do cancel. Leaves us with y. And this time it's a negative 3/4. And this time we replace it with this parenthesis. And we say 4 times negative 3/4. This 4 times negative 3/4, replace it right in there. That's going to give us negative 3. Then we add to get 3, which will give us the 0. We add the 3 to negative 3, and we get that 0. All right, it gets us to 0. So that's the idea. We're looking for how do we get 0? And obviously, if you put a negative 3/4 over here, it ain't going to be 0. But it doesn't matter. As long as you've got it right here, it's good. Same thing here. You put the 5/3 in over here, it's not going to give us 0. That's the idea, but it will give us 0 on the left parenthesis. So as long as it takes care of one of them, we're good. But we want to show both options. So again, repeat that procedure in your head. Always think back. We can leave them improper fractions if we need to, okay? Now, let's take a look at another one here. This one's a little odd. looks like a GCF happened, all right, but it's already been taken care of. Maybe this started out like 3k squared minus 10k, but we've got a k out here by itself. It has no plus, it has no minus attached, but it is attached to the parenthesis by multiplication, so it, folks, is a factor. If you want to, you can put a little parenthesis around it. No need to, but we can put a little parenthesis around it, right? There we go. Let's make that prettier. There we go. So you say, well, Ernie, what's the deal? We check both factors. This is a factor. 3k minus 10 is a factor. So we're going to first off say, how about it? K equals 0. Well, that was easy. Yeah, because k by itself would have to be 0 if we're going to get a 0 from this equation, all right? The other side of the coin is a little more, work it out. 3k minus 10 equaling to 0. Notice we're always setting things equal to 0. That's our game of the day. Why is it important to be 0? Because that's how we get out of these factoring equations and solve for them. And let's see, we're going to add 10. We're going to add our 10 to both sides. We got 3k, and we have 10, and we have it all equal. And you say, Ernie, that didn't go even, does it? You're right, it doesn't go even. We're going to leave it as an improper fraction. We're going to divide 3 into 10. You could call it 3 1/3, or we could put it as 10 over 3. But there are your two solutions. And again, when you substitute that 10 over 3 back in here, you're going to get 10 minus 10, which gives us the importance of being 0. 0, 0, 0. There we go. All right. So let's see. That's going to practice, folks. We're just going to practice what we've been preaching up here a little bit. And sometimes it expands. Sometimes you have, wow, 3 situations. But remember what I said, C is out there by itself. That's why we just see another example. So each time you see one of these, you work through it with me, you work through it on your own, and you say, hey, I see where it's going. I see what it's doing. I see what's happening. So how about it? I've got C equals 0. You know that story. We don't have to worry about it. C's out there by itself. So this time we have 1, 2, 3 opportunities to have a 0. 1, 2, 3 factors, all right? So we're going to do C equals 0. That's one of them. 3c plus 5 equals 0. That's another option. And 2c minus 7 will equal 0. So this one kind of spreads all over the place. Spreads out all over the place. But we've got a lot of possibilities. So here we go. We will subtract our 5. Subtract 5 from both sides there. And that's going to leave us with 3c. And notice, folks, when we subtract 5, the sign becomes negative over here. So watch your signs. Always be sure to keep that minus 5 to both sides. And we're going to have c equals negative 5 over 3, because we're just going to simply write 5 over 3. Keep the negative. Keep the negative, because a negative divided by positive is a negative, folks. Got it? And let's check out what happens here. We're going to add 7. All right. And we have 2c equaling over here to 7. Again, we can make that 3 1/2. That's what happens when you divide 2 into 7. But let's just leave it improper. Equals 7 over 2. Now, if we go back and plug this 7 over 2, substitute it in, you're going to get the 2's to cancel. It's 7 minus 7. Yes, we get a 0. Over here, put the negative 5 over 3 in there. The 3's will cancel. Negative 5 plus 5, you got another 0. And of course, this one was really straight on easy. Very easy. C is 0 because it's by itself. So these are the options. 1, 2, 3 possibilities for solutions to come into that problem, okay? So we're looking for zeros. We're looking for the zeros. A little practice. Let's take a look at this next one here, okay? We've got 3 options. You say, wait, Ernie, you put a 3 in front of the variable. That's okay. It's still a factor. You could pretend that we could put a little parenthesis right around it, okay? So it is a factor there. It is a factor there. So let's see what we're going to do. We're going to pick up 1, 2, 3 factors. So 1, 2, 3 equations. So how about it? We're going to pick up 3t equaling to 0. We're going to have our t minus 13 equal to 0. Now draw a line through here so we keep it straight. And then we will come back with 4t plus 5 equal 0. All right? Well, it looks like I'm going downhill a little bit there. That's all right. It's the week after Christmas. We're all going to relax anyhow, okay? Let's see what happens here. It says 3 times something. 3 times t gives me 0. Remember that property earlier we said that only way you can get a 0 is to say 3 times 0 or 4 times 0 or a number times 0 or 0 times 0. But the only way this is going to work is t, folks, must be 0. By the way, 3 goes into 0 times, all right? If you divide 0 3 ways, you still have 0. I have many students that want to say, oh, that's 3, or that's a negative 3. No, no. If it were plus, it would be a negative 3. But this is 3 times what number gives you 0? Just think, folks, it's got to be a 0. It's got to be a 0. This one pretty easy. Add to 13. And guess what? We are ready to go home on this one. T equal to 13. Now, how about it? Let's subtract our 5 off this side. And we have, wow, we have 4t. And he have negative 5. You get the idea? This routine is over and over. It's just practice, okay? It doesn't change much. We always set things equal to 0. And we're going to divide by 4. It doesn't go in there evenly, but we'll leave it an improper fraction. Negative 5 over 4. Quick check. Obviously, 3 times 0 is 0. 13 minus 13, that gives us a 0. All right? And 4t plus 5. Well, if it's negative 5 over 4, that 4 is going to cancel. It leaves you with negative 5 plus 5. So we're looking for ways that this could be 0, that this could be 0, or that this could be 0. All right? So you want 1, 2, 3 solutions. Everywhere you see a variable, there needs to be a solution. No matter how obvious you think it is to me or how obvious it is to someone else, spell it out. Put it all down there, okay? Be sure you put it all in there. All right, so that was pretty easy. Oh, wait a minute, Ernie, you just messed things up, didn't you? Wow, you had to put a binomial up there that has x's, more than one x value, or it's not put out in parentheses. What are we going to do? Well, we're going to go back to our good old buddy. You got it, the GCF. All right, so let's rewrite our problem down here. X squared plus 6x equals to 0. By the way, what we're going to be noticing when we work through these problems is we want to keep a 0 in the problem. This was set up good to go. Now we're going to see a couple of problems here in just a minute where we don't have that luxury, but we're going to deal with it, okay? But GCF, remember what it stands for? Greatest common factor, all right? So what we're going to do, we're going to notice there's an x that belongs to both of these. An x belongs to both these terms. So we're going to take it to the outside, and we're going to write what's left over here, which is x plus 6 on the inside equals to 0. Now, it's pretty obvious that 0 is a solution because if you put 0 squared plus 6 times 0, you've got 0. And look what happened here, folks. There it is. There's the x equals 0 part. Now, we also have this x plus 6 that has to equal 0. And that's not so bad because this is a nice integer value. You don't have to do any dividing. You just have to subtract 6, both sides. There we go. And it looks like this. It looks like x equals negative 6. You said, well, that's just like those problems we did earlier. Right, you've just got to get to the parentheses part. All right, you've just got to get to the parentheses part. So you set it equal to 0. You see a greatest common factor. You jump on it. You know what to do. Pull it out, write what's left behind in a parenthesis, and then solve both pieces. And obviously, negative 6, you say, does that work up here? Well, let's see. Negative 6 squared is 36. 6 times a negative 6 gives me negative 36. 36 minus 36. They cancel each other out. We're at 0. So we got good answers. We got great answers on that, okay? So again, always go back and check into your original equations. Make sure things are good, all right? Take a look at this one. Another quick one here going for us. GCF moment. All right, you got a GCF. Let's just write this thing down here and let's rock with it. So we got 3w squared minus the 4w. You see, I see, we all see there's a w that ends both those terms. GCF, w, all right? So pull it to the outside. There we go. And what have I got left behind? I have 3w minus 4. And we have that equals 0. That's important. Importance of being 0. That's where we are today. All right, it's a great moment here. So now let's set these two factors. You say they're two factors? Of course they're two factors. I wouldn't lie. There we go. First factor, second factor. So set them both equal to 0. Set them both equal to 0. So we got w equaling to our 0. We have 3w minus 4 equaling 0. I'll draw a little line right down there. That's solved. That's good to go. In fact, folks, if you put 0 in here and 0 in here, you got a 0 minus 0, which is, hey, 0. If you see zeros popping up everywhere, life is good, all right? This next one, let's see, not quite so easy, but we can deal with it, all right? We are going to pick up, it looks like, you say, Ernie, what are we going to pick up here? Well, we're going to pick up adding 4 to both sides. And we're going to have a 3w equaling to, looks like, 4. Now we're going to make that into w equals 4 over 3. Now, when you're checking on this one, folks, remember, an important little thing here, when we check back through it, you got to do your squaring and then you multiply by the 3, all right? But this one will give us a fairly nice deal here, because what happens is once we run this value in here, it is going to give us a pretty little bit of, looks like 16. Does that look right to you all? Let's see. Actually, not quite 16. It's going to be 16 over 3. It's negative 16 over 3 for that part. This is also, when you square your w squared, you're going to get 16 over 9, which is also going to have a little bit of cancellation. It's going to give you 16 over 3 also. And those are going to cancel out to give you 0. Fractions sometimes make you nervous, but just remember, you can go back and plug it in this parenthesis and check it through here. It should work there also. Should work there also. And it can. It can. Just be a little more complicated. Sometimes you're going to have a nasty old squared fraction. Okay? So let's take a look at this one here. A little different order here, but still this concept is GCF time. It's the greatest common factor. So let's take a look at that. There's a y, but also we can divide out 2. Let's divide out 2. So we can take 2y to the outside and see what we have left behind. Now don't breathe. Don't get too excited here. It's going to be a 2, because 2 times 2y gives us that 4y. Minus, got to keep that minus sign rocking there. Looks like we're going to have minus y, because 2y came out. So we only have y left over. So let's check and see what's going to happen here. Again, 2 factors. 2y equals 0. 2 minus y also equaling to 0. Just set them up and solve. It looks a little funky, but you know, once you get y by itself, just move it to the right. This one looks great. Divide by 2, you get 0. Okay, very important. This time, let's add y. Add y to both sides. And we've got 2 equals y. So the 0 came from the 2y. The 2 came from 2 minus y. And obviously 0 minus 0 gets us there. If you put a 2 in both of these places, you're going to have 8 minus 8, which also gives you 0. So they do check back through. They check back through. So it's all the same routine. All the same routine. Oh, until I throw you something that looks like this. Let's see what we got here, folks. X squared equaling to 7x. You say, there's no 0. You're right, there is no 0 in this problem. But you know what we're going to do? We're going to make one happen. We are going to take our x squared equals 7x right off the bat, and we are going to subtract 7x from both sides. Now be careful. Be careful when we do this, because we have x squared minus the 7x. You cannot put those together. But look what happens over here. You wonder if the 7x's disappear. They disappear, and that's because they give us the importance of being 0. So let's take our GCF time, all right? Time for the greatest common factor. Pull an x out through here, and we have x minus 7 left behind equaling to 0. And if you look at that, hopefully you're starting to get good at this. We've got x equals 0, but we also have x minus 7 to equal 0. Options, they are options. And here you get, obviously, x is 0. That's not changing. But let's add the 7 here. Add the 7. And we have now x equals 7. Does it check? All right. 0 squared is 0. 7 times 0 is 0. So that's a good answer. Again, go back to the original. Go back to the original. How about putting in 7 there? 7 squared is 49. 7 times 7 is 49. It checks also. So it does. It makes 49 equal 49 or 0 equals 0. So it solves your equation really nicely there. Let's take a couple more here. Got the next situation here. 4a squared equals 6a right down here. And storyline here, again, I don't see a 0. We need one. All right, so let's get one. Let's get one here. So we're going to move the 6a to the left. And that's going to leave us 0 on the right. We're going to have 4a squared minus 6a on the left. Now you say, where do we go? What do we do? How do we get out of this one? Common factors. There's a greatest common factor going on here. There's an a and there's also a 2. So take it all out. So take 2a to the outside. That leaves us with 2a minus 3 on the inside. You see where I'm going? Let's do it fast. Let's go furious here, all right? 2a equals 0. Boom, a is 0. And on the other side, I've got 2a minus 3 equals 0. Add the 3. And we have 2a equal to 3. And that's going to give us a equals 3/2. We can think about it as being 1.5. Again, plug it back in here. Both sides, obviously with the zeros, work very nicely. When we put 3/2 in over here for 6a, we put it in for 6a, it looks like it's going to come out to be 9. And when I do the squaring moment over here and multiply by 4, it's also going to give me 9. Okay, so the 9 equals 9. Easy to check these, guys. Easy to check these. Zeros are awesome because you're looking for the same number on both sides, or you're going to see them go. All right, we're real quick here. Look at one last problem here. Okay, no last problem, I understand. I'm getting close to the end of the show. So, hope this has been helpful for you. Always set things equal to 0. The importance of being 0 when you factor and you solve. We're going to go a little deeper into our next show tomorrow. Be there with us. Thank you for tuning in today, and hope you have a great evening, and we'll see you back tomorrow for another show.